to our computer science learning event for December. And if you're waiting, please share in the chat what brings you here and what is your role at your office or school. Okay, so today we will be covering algorithms and programming and feature activities from the Hour of Code to celebrate Computer Science Education Week. Okay, next slide. My recording button just popped up. Okay. So hi, aloha kako, welcome everyone. I'm Janine Nakakura, resource teacher at OSID. And here's my colleague, Faith Ishihara. She's an education officer also at OSID, and we both work on the computer science team. Okay, next slide. So here's our agenda for today. If you click on the link to the left, that big agenda underlined, if you click on that, that will take you to our agenda with all of the links to the presentation and just give you the link to the recording and the actual slides when we're done today. So just look at that agenda for whatever you need. It's a one-stop shop. Okay, next slide. So let's start off with our bell ringer. And in the chat, can you put down or type in, where have you heard the word algorithm mentioned? So put your answer in the chat. And if you can, provide a related resource link, if possible. And while you're thinking or trying to find something, let's go to the next slide. I will give you, access to the agenda. Sure. Sorry about that. I will share that with all of you. There you go. Forgot about that. Thanks for reminding us, Mickey. So back to my example. I did just a search on algorithms in Hawaii, and I came up with this article from Hawaii Tribune Herald from February, so it's relatively recent. And the part that called out to me was that algorithms decide what ads appear based on what content you look at, like, or share. So when you do a search on Google, then things start popping up related to that, or you go online shopping, you find ads that relate to what you were searching for. When you go on social media, it's like, oh, how did they know I was looking for new running shoes? Boom, all these ads start turning up. So if we go to the next slide, for those of you who are watching the recording, I'll try to put the chat responses into this slide presentation so you can see what people were responding with. So I put down, what I just mentioned about social media platforms and the algorithms deciding what ads you see based on what you were looking at or, what you liked or shared. And there's a link. Okay, so Mickey said algorithm is a set of rules to perform a task. Yes. Okay, so thank you very much, Mickey. Okay, next slide. So the reason why I asked you about algorithms is because core concept number 4 deals with algorithms and programming, and the sub-concepts are algorithms. Okay, I got to go closer because it's so small. Algorithms, variables, control, modularity, and program development. And if you click on that link to the right, you will see that flyer in bigger font so you can read it. Okay, next slide. And again, here's our progression chart with the core concepts on the left, running down those colored blocks, and then going across from early elementary all the way to high school, the standards, and then on the back, more standards. So don't forget to look on the back. Okay, next slide. So today, the standards we will be covering come from elementary, middle, and high school. So that's the 1A, 2, and 3A. And we're going to decompose the steps needed to solve a problem. We're going to systematically test and refine programs. And we're going to design and develop computational artifacts working in teams, okay, and using collaborative tools. Okay, next slide. So I'm going to hand it over to Faith, and she will take you through a plugged activity and an unplugged activity for the Hour of Code for elementary students.
Okay, thanks, Janine. So this year, the theme for CS Ed Week is CS Everywhere. And so we want to encourage students and teachers to explore the relationship of computer science to the other areas of study. So whether it's a subject in school, the different industries you might be going to, different career paths, there are connections to computer science everywhere in our lives. So on this slide is a link to the Hawaii CS Ed Week app with activities that are happening all week this week, and it's super easy to register for them and join in on the fun. So here's a little bit more about Hawaii's CS Ed Week, and if you click on this link, I will take you to a slide presentation that was presented yesterday during the kickoff, where we had Governor Ige and his wife, First Lady Dawn Ige, speak about welcoming everybody and the excitement of computer science in Hawaii, and also Interim Superintendent Keith Hayashi and other notable people on the islands to speak about the importance of every student having these experiences. So talking about making those meaningful connections, Code.org this year has put together cross-curricular modules, and they're called Computer Science Connections, and they're for kindergarten through grade 12. So students can learn about coding as it infused in the other areas of curriculum that they study. So there's this great big number on the bottom of the screen, and that's how many people are served with Hour of Code. So very exciting. You're one of those over 1 billion people making history in the largest learning event. So exciting times. Now we're going to take a look at one of these cross-curricular activities, and it's called Poem Art. And it combines when you create poetry, it's a lot of feelings, a lot of moods, and how to get coding to play a part in that. So let's take a look at this activity. So and I'm going to play this video, and it's going to help us to see what we're going to be doing in the next few minutes.
My name is Kaya, and I'm a poet and a computer science student. I've learned so much from coding that's made me a better poet, and so much about my poetry has made me better at coding, just because you have to really think about the words that you choose and what you're going to create once it all comes together. Over the next hour, you're going to learn about computer science and poetry by creating an animated poem. In essence, poetry is making art with words. I create poetry to express myself. I try to stir the audience's imagination and emotions when I write by using my unique style and rhythm. Just like art, poems can be interpreted in many different ways. The same poem might mean very different things to different people, and each poem has its own mood. Mood is the feeling you get from a poem. Sometimes people associate certain colors and imagery with different moods. For instance, the color yellow makes me feel cheerful. And when I think about a mood like fear, I sometimes picture a dark and stormy night in my head. In this activity, you'll have the opportunity to illustrate and animate the mood of a poem based on how it makes you feel. Let's take a look at how you'll do this using code. You'll see that your screen is split into 3 main parts. On the left is the play space. This is where your animated poem will show up. Each poem has a title and an author. This middle area is the toolbox. New blocks of code will become available in this space as you go through the lesson. The space on the right is the workspace. You can drag blocks out of the toolbox and into the workspace to build your program. The instructions for each level will be up here at the top of the screen. If you want a hint, click on the light bulb. First, select a poem you like. There are all kinds of poems, and you can choose a new one on every level. Next, you'll drag blocks from the toolbox into your workspace to animate your poem. You can choose a background color or effect that matches the mood of your poem. Then click Run to see your poem in action. Spend some time reading the different poems and find one that sparks an emotion in you. Think about how you feel and how you can communicate that feeling through imagery and code.
Okay, so based on what we just learned, we're going to go to this site. Oh, and actually, well, okay. And on the left, select a poem and then use tools from the toolbox and slide them over to the workspace and see if you can try to get scenery or colors or movement to represent the mood that the poem is emoting. So I'll take us back to the link for the activity. Hold on. Oh, looks like Janine has it. Thanks, Janine. And here's another link. So if you come to Poem Art and hit Start, and I'll put this in the chat too. And we can exit the video. And I'll give you a minute or two to play around with it. I hope everybody has found their space. So again, first we're going to select a poem, pull down this drop-down menu, and then use tools in the toolbox and slide them over to the workspace. So when run, I might, well, let me pick a poem. I'm going to select this one about the clouds. And I'm going to change my font to Arial. And I'm going to change my background. And this poem talks about golden daffodils. So I want to kind of show some of that. So I pick a background like this. And when I hit run, it's going to show us the different lines of the poem by William Wordsworth and how it goes from the clouds to the daffodils to the valley and the nice breeze. So I hope you're having fun playing around with this. And I'll give you another minute or so while I switch back to the slides. So has would anybody like to share what they did, or I don't want to put anybody on the spot, so you can continue to have fun with that, and I'll just go on to sharing. Oh, Alyssa said they did it with the third graders. That's awesome. And then I got up at 5 this morning to attend the National CS Ed Week where they were doing this poem art, and a 10-year-old student kind of went through this whole process, and she actually I think it was about an hour's time they had, so she actually took us all the way. This is what I just showed you was like step one, really scratching the surface. And she takes us all the way to much deeper, much more advanced things that you can do with these poems and art. And it was really, really fun to see the process. And I encourage you to take a deeper look too. And I put the link in the slide of the video from this morning, and you can follow along the steps and through the process as she did. So now I'm going to switch over to an unplugged activity. And this is where, you don't need computers. And so if we look at the top box, it's our example. And there are directional arrows underneath it. And one of the arrows is giving us incorrect information. And we call that the bug. And so we have to debug this program so that it runs properly. So if the directional arrow is coming in from the left and we go toward the right, so that's correct. And then we have to go up. There is no down option. So there is the bug. And then switching that to an up arrow and then moving to the right to exit. So if we look at the second one, the little bigger one underneath that, it's the same process. We're coming in from the left and moving to the right. So that arrow is correct. Going down, again to the right, going up. And then can you see where the bug is in this example? So it's this third directional arrow from the left. So after going up, you have to go right. There is no left. So yeah, awesome. The left arrow should be right. Absolutely. Thanks, Alyssa. And so now I'm going to let you try. So I did one, we did one together, and then now it's your turn. So take a look at the 4 options and take a look at the little maze that we have to go through, or and which of these is correct? So is it the orange? Is it the lime, the grape, or the brownie? One of them is correct. Awesome. So yes, the purple one is the one without any bugs. And that's the program that's going to run properly. Thank you so much. Thanks for participating. So now I'm going to turn over the sharing to Janine, and she's going to take us through some secondary activities. So I'll stop sharing.
Okay. Faith and I practiced this morning, so hopefully this will go smoothly. Okay. Cross your fingers. Here we go. Alrighty, so here is my screen, and we are on slide number 19. Can you all see that?
Mm-hmm.
Okay, so I am starting with an unplugged activity for high school. So if you click on the link to the left, right here, it will take you to color by pixel, and here are the directions. You do not need a computer for this. All you need is paper, pencil. And so it starts with something very basic. And here are the directions. So the answers are here. Don't look too fast. And then they take you to more complex drawings. And what they want you to do is to write the code or the program to make this drawing. And so what we're going to do, since we don't have much time, and here they have all the templates, okay, so everything is there. What we're going to do is go to the next slide, slide 20. And here's that simple smiley face program that they have in the lesson. And here are the directions, the program. So what is the last one for block 7, number 7? What would the directions be? Can you put that in the chat? Okay. And Faith, could you tell me what's happening in the chat, since I am not able to see?
Yeah, so Alyssa has 3, 4 green.
Okay, let's see if she's on the right track. Again, like I said, the directions and the answers are here in the lesson. So did she say 3, 4 green?
Yes.
Okay, well, that is the correct answer. So now she can move on to the more complex drawing, and then the students can create their own program. Okay, so that's just something very simple. If you don't have a computer, something you can do real fast. Okay, so the next one I'm going to show. Any questions, by the way? I can't see the chat, so I'm just going to plow through this. Okay, so here's code.org artist. It's a plugged activity for middle school, and I'm just going to show you this real fast. Okay, so if you click on that link, and the good thing about Hour of Code is they give you a little summary of each activity, so you can kind of get an idea of what it's about. So what we're going to do is try to make a square, something very simple. Okay, so using the right turn block and move forward block. So let's see, move forward, turn right, and then, so I'm going to do something wrong. I'm going to put a bug in this, okay? And you can tell me what I need to do to correct this. Okay, so it says here 8 blocks. So I have 1, 2, 3, 4, 5, 6, 7, 8. Okay, I'm gonna put one more here just to see what happens. Okay, so let's run this program. And it says I did it, but I could have used only 8 blocks. So what can I do to make this even better? It's okay, they said, but I could actually take away a block. So what should I do? Can somebody, Faith, can you tell me what's in the chat? What are any suggestions?
So Alyssa said delete the last turn right.
Okay, let's do that. Let's throw it away. Okay, let's run it again and see if that works. Alrighty, so we did 7 lines, and they like this even better. Okay, so you can go on to more complex drawings like that, or that, or that, and I won't do that right now, but you can see the more complex drawings. Okay, so we're going to go to the next activity, which is Grace Hopper debugging activity for middle school, and it's plugged, so you do need a computer, but it's pretty simple. You just go to this lesson, and I tried out all of the lesson, but the part that I think would be most useful for a classroom that I can understand is this activity number 2, Scratch Ed's Debug Studio. So I'm going to click on that link, and it takes me here. So let's do the first debug it together. Okay, so let's run this program. Okay, it meows once. So the instructions say when the green flag is clicked, the cat should say meow, meow, meow in a speech bubble and as a sound. But as you notice, the speech bubble happens before the sound, and it only makes one meow. So how can we fix this program? So let's look inside. All right, so we can see the steps for the program, and we want it to say meow. We want it to say meow, and we want it to say it 3 times. So I'm going to put it in here, I think. I hope this is okay. Okay, start this, and we want the speech bubble to appear before or during while it says meow. Okay, so let's see if this works. Let's run it. Okay, so there, we just debugged our first program. Okay, and then we can go back to our slides and see that it progressively gets harder. So you can try these out with your students, or give them each, a group one to do, and see what they can come up with collaboratively. So I'm going to turn it back over to Faith, because we're running short on time and we've got a meeting we have to run off to. So yes, here we go.
Okay. Thanks, Janine. So each month when we do these learning events, we share a book from our statewide ebook collection. So this month I wanted to feature Grace Hopper. And this whole CS Ed Week is held in her honor. It's usually the first week of December, because her birthday is December 9th, 1906. And so a little bit background about her. is that she was born in 1906 as Grace Murray, and she didn't play with dolls, but she, at age 7, she opened the back of her alarm clock, and the springs and the gears all flew out, and so she didn't know how to put it back together again. So she got another alarm clock and opened the back, and the same thing happened. And eventually, her parents gave her 5 alarm clocks, and they all had the same demise. And their parents were just so happy that she loved learning. And she graduated high school at age 16. She went on to Vassar College and earned a bachelor's degree in math and physics. She went to Yale University and earned a master's degree in math. And the year she graduated, she married and changed her name to Grace Hopper. And then Vassar College invited her back to teach algebra, calculus, and statistics. And she joined the Waves in 1943, which is the Women's Accepted for Volunteer Emergency Service, an all-female unit in the Navy Reserve to help with the war efforts. And because of her math background, the Navy sent her to Harvard to work on the first automatic digital calculator called Mark I. And it read instructions from long pieces of paper with holes punched in them. And she first, when she saw the Mark I, she wanted to take it apart, but she read the blueprints instead. And during her 3 years at Harvard, she went on to work on the Mark II and III. And then, one day she came upon this bug, this moth that was in the computer, and she removed it and taped it to the logbook. And till today, when we solve problems in computers, we say we're debugging the computer. And in 1949, she went to this private company, and they had a UNIVAC computer which ran on vacuum tubes and read the code off of magnetic tapes. In 59, the Department of Defense had about 200 computers from different sources, and they all ran off different languages. So she was tasked to make some uniformity, and she put together a committee and established COBOL, which is the Common Business Oriented Language. So if you wanted to do business with the military, you had to do it in COBOL. So that became the most widely used computer language. And she was eventually promoted to Rear Admiral and the first woman to achieve that rank. There was a ship named after her, USS Hopper, and she received the National Medal of Technology, which is the highest honor in the country for engineering and technology. And she passed away in 92 at the age of 85, and she's buried at Arlington National Cemetery with full military honors. And I was telling Janine this story, and she said, hey, wait, she had gone to Harvard with a few of our colleagues, and she saw Mark I, and she took pictures of it. And so she shared her pictures with us. And so here we are, some photos of the actual Mark I that Janine took, and a picture of the group that was there. And about 5 of the people in this group are colleagues of ours from our office. So really exciting to make that connection. And the Mark I has since been moved from Harvard, but and we have a link in there to the article about where it went and how long it took them to get it there. And so if you are interested in this or other ebooks or audiobooks from our statewide collection, please go to Sora app and check out the collection. So,
All right. So Alyssa has to go run off, and then we got to go to the meeting. So we're going to wrap this up real fast.
So here are door prizes for Janine to talk about.
So we're gonna look at who has the most letters in common with Grace, and we'll send you a prize pack unplugged. And I think it's Terry and Alyssa. So yeah, look for something from us. And this is the prize pack. So thank you for joining us today, and we're off to our next meeting. I'm gonna stop the recording. Thanks everyone. Bye.
Bye.
Stop the recording. Stop the recording.